while the arrow tree and C2 is used to set a delay response time. Response time, what I mean by response time is when the tone comes in, how fast is it decoded at the decoded and the output, how fast is it being decoded and the output being generated. That's the rate it takes, the time it takes for the tone to come in and come out as in digital form. Now, what this circuit does is just to identify the number you press on your mobile phone. If it's 1, it's going to give a 00001. If it's 2, it's going to be generate a 0010. If it's 3, it's going to generate a 0011. Now remember, 1 is high logic, 0 is low logic. So that's how the DTMF circuit works. Now the output of the DTMF is fed into the input, the port A of the microcontroller. I think I have that here. Now the wires from the DTMF is connected to the microcontroller. You'll notice you have like 5 wires being connected to the microcontroller. 1, 2, 3, 4, 5. Now the 5th one is just used to sense when the microcontroller, the DTMF is sending a, just to tell the microcontroller the DTMF is sending a new DTMF tone or being decoded output, a new DTMF tone. So the microcontroller, okay, DTMF. So when you press 1 on your mobile phone, it's being received by the Bluetooth module here. Now the Bluetooth module sends it into the through the capacitor, which filters the sound, the tone or the sound. Now this reduces the audio level, and combination of the resistor and the 2 resistors reduce the audio level, more like a voltage divider. The tone is decoded here, and the binary output, the digital form of the tone, is outputted at this point. Is 4 wires, 11 to pin 14. Now the microcontroller senses it. If it's a 1, it sends a high logic. Okay, if it's a 1, process, and the microcontroller understands if it's a 1, then it does the response. 1 is to switch on, okay, 1 is to off. Okay, when you enter the right code, let's assume you have you are making use of a 4-digit code and your password is 1, 2, 3, 4. Now when you enter 1, it goes into the microcontroller. The microcontroller waits for the next number. If you press 2, it acknowledges 3, 4. When it completes the 4 digits, which is the 4th number, and it compares with a pre-stored, there's a pre-stored password on the microcontroller which you've selected during your programming. And if it's 1, 2, 3, 4, which means it's going to compare what comes in from the DTMF. If there is a match, it sends a high logic to the transistor. This activates the transistor and activates the motor, just like the demonstration that was done here, where the high logic flows in this way and activates this and enables the motor to spin. It activates the motor. If a wrong password was entered, what happens is, instead of sending high logic to the motor, it sends a low logic to this motor, which means the motor is deactivated, the door is not being opened, and sends a high logic to the modem and also to the buzzer. When the high logic flows to the buzzer, it activates the alarm, so it generates a beeping sound while the mobile phone, just like the motor, closes the contact of the relay and activates the call button of the phone. Now on the mobile phone, what you have is the last number being dialed on the phone is like a security number, and the wires connected to the call button on the phone is connected to the contacts of the relay. So whenever the contact closes, it's like pressing the call button. So when you press the call button, what happens is it redials the last dialed number, which is the security unit number. Okay, so that explains the circuit. The power supply part of it is normally you're making use of a 220 volt power source, and you can't connect that directly to your microcontroller circuit because the microcontroller works with just 5 volt DC and your power source is 220 volt AC. So you need a circuit that converts the 220 volt AC into 5 volt DC. So this is the circuit here. This is like your plug. The 220 volt flows into the transformer. Now the transformer is a step down transformer, steps it down from 220 volt AC to 12 volt DC. It's been converted to 12 volt AC, sorry. Now it's been converted to DC by this bridge rectifier. It's filtered by the capacitor. The 12 volt DC now is being filtered by the capacitor. This is like a battery for backup, and also it charges the battery. Now when the switch is closed, the 12 volt flows to this point and into this is the voltage regulator, which regulates it to 5 volts. The 5 volts is also filtered. Now the 5 volts is used to power the microcontroller, while the 12 volts is used to power the motor or the relay. Okay, that explains it all.